this video, we are going to be looking at circle geometry, and the subtopic we'll be looking in this topic is chord, arcs, angles in a circle. Now, these are the three things we are going to be explaining, three terminologies we'll be explaining in this topic, which the first one is diameter, the second one is chord, and arc in a circle, and arc. So after this, we are now going to be explaining what we call angles in a circle. Now let's start with diameter. All these terminologies, they are all from a circle like this. Now, having this circle, everybody knows that a circle will definitely have a center. Let's explain what is diameter. A diameter is a what? Line that cuts a circle into two equal halves. This particular example on the board now is a line of diameter, because a diameter is like a line that will pass through the center. It will definitely pass through the center. That's diameter, meaning that it cuts this circle into two equal halves, something like this, 1 and also 1. So this is a diameter. Now, after diameter, now let's move to chord. Chord and diameter, they are partially similar. They are similar in the sense that a chord is also a line that cuts a circle into two, but not two equal halves. It's a line that cuts a circle. So a chord will definitely cut a circle, but not into two equal halves. Exactly. It's not into two equal halves. Now, look at this chord now. This chord actually cuts this circle into two. This is a chord like this now. You can see that if this is the center, this chord did not pass through the center. Now, let's look at this chord. This chord divides the center into two things. What are they? We have arc. This is an arc. This is also an arc. You can see that I'm using this chord now to explain what arcs is all about. So again, a chord is a line that cuts a circle into two, but not equal halves. And a chord did not pass through the center, unlike diameter that passes through the center. So this arc now is into two, whereby we have it as the major arc. You can see this one is mod, and also the minor arc. So a chord divides a circle into two, which is the major arc and the minor arc. And also, despite the fact that we can call this thing major arc and minor arc, we can as well call it segment. So this is a major segment, and then this is a minor segment. So we have major segment and we also have minor segment. Now let's go to example 1. Now in this example 1, which says the radius of a circle is 10 centimeters. The length of a chord of the circle is 16 centimeters. Then we have to calculate the distance of the chord from the center of the circle. So let's firstly draw our circle. I'm answering example 1. So this is a circle, and you know, circle will definitely have a center. So this is a center. Then back to the question, which says the radius of a circle is 10 centimeters. We all know that radius means when you cut a diameter into two. So let's assume our diameter is like this, something like this. So if I should cut this particular one into two, then I will be having my radius as this. Let me clean this space here. So this is my radius. I have my radius like this. So let me name it R, radius. So the radius is 10 centimeters. So I have my 10 centimeters here. Then I was told that the length of the chord of the circle is 16 centimeters. Mind you, I told the length of the chord we're actually going to be like this. So this is the length of the chord, meaning that this bigger part will be the major arc, while this smaller part will be the minor arc, or this bigger part will be the major segment, while this small one will be the minor segment. So the length of the chord is 16 centimeters. So this length here is 16 centimeters. Then the question says, calculate the distance of the chord. The distance of the chord from the center of the circle. This is the center of the circle. The distance of the chord, meaning that from here to this place. So we have to calculate the distance from this place to this particular place, which means it's going to give us this place. So let me name this one L. So we have to look for L like that, because this L is the distance of the chord from where? From the center. So we are looking for this. Now, this particular thing looks like a triangle, a right angle triangle. So we have our angle 90 like this. So let me take this thing out. If I take this angle out, it looks something like this, like this, like this. But I have something here. So how do I work on this one? How do I eliminate this part? Is by saying, okay, let me assume all this length by dividing this whole length divided by 2, because this is like as if I'm cutting this arc into 2. This line cuts this minor arc into two equal parts. So meaning that this part is going to be 8 centimeters and this part is also going to be 8 centimeters. So here is going to be 8 centimeter, while here is also going to be 8 centimeter. I don't need this part because I will use this particular aspect to calculate my right angle triangle. So I'll be eliminating this 8 centimeter away, whereby I will use this 8 centimeter. Again, this particular chord, this line cuts this chord into two equal parts. By saying this part is 8, this other part is also 8. Sorry, 8 centimeter. So this part also is also 8 centimeter. I'm looking for this particular piece. Then my radius here is 10 centimeter. So now this looks like a what? This looks like a right angle triangle. Now, how do I calculate this? We all know that hypotenuse, the square of hypotenuse equals to opposite square plus what? Adjacent square, from the law of Pythagoras. So now our hypotenuse here is 10 square, which is 10 centimeter. So I will square it equals to the opposite. Opposite is going to be this L. So that will be L centimeter. And our adjacent is 8 centimeter plus 8 centimeter. So solving this now, making my L straight of formula, then I'll have it as L square equals to, if this come over to this place, that gives me 10 square minus 8 square. So I have it as L square equals to 100 minus what? 64. Because the square of 8 is 64. If I subtract this, I will have my L square should be 36. And then finally, I will look for the square of what? 36. And that gives me 6 centimeter. So meaning that the distance of the chord from the center of the circle is what? 6 centimeter. So the value for my L is 6 centimeter. And that is what we are asked to calculate in the example 1. Imagine that the example 1 now is talking basically on what? On something related with chord and what? An arc. Chord and arc. Where is the arc? This is the arc. And this is also a chord. This is the length of a chord. And at the same time, it's also the arc. Which type of arc? This is a minor arc because it's the smaller one. And this is the major arc. You can also call it the major segment or the minor segment. Now, let's go to example 2. Now, the example 2 says, let me draw my circle first, because this chord, arc, and angle, all of them, diameter, everything, they are related with what? Circle. So circle will be the first thing I'm going to draw first. Now let's go to this question. And remember that all circle will definitely have a center. So let me indicate my center here like this. Okay. Then the question says, example 2 says, a chord of length 24 centimeter is 13 centimeter from the center of the circle. Okay, let me read the question again, which says a chord of length 24 centimeter. Let me take my chord again. Okay, the chord is what? 24 centimeter, like this. So now said it is 13 centimeter from the center of the circle. This is the center of the circle. From the center is what? Is 13 centimeter. That is what they are saying. This is the center. And you see that, let me circle. This is the center. So from center to this place is 13 centimeter. Then the question says, calculate the radius of the circle. Mind you, like I said, the radius is like as if you are taking just a single line means radius. If I join this to this place, like if I join it like this, then we have it as diameter. Because diameter will be one part like this is the diameter. Another part like this is also a diameter. A diameter is the line that touches the circumference of a circle and it passes through the what? Through the center of the circle. That is what diameter is all about. So now let's calculate this thing. This looks like a triangle as well, like the first example we did. Which example 1? So I will bring this triangle out. If I bring it out like this, it looks something like this. I have my angle 90 like this. So you can see this line cuts this chord into two equal parts, like I said earlier. So equal, the word equal, that means this from here to this place is 12 centimeter, and from here to here is also 12 centimeter. So this particular place will be 12 centimeter. This length here from the center to this place is 13 centimeter, and we are asked to look for here. Let me name this one R. So this is a right angle triangle. We are still going to use Pythagoras theorem to solve this value, to know the value for this radius of the circle. So by still saying the hypotenuse square equals to the opposite square plus the adjacent square. So the hypotenuse square is unknown. Let me represent it as R square equals to 13 square plus what? Plus 12 square. So if I have it as R square equals to 13 square is 169 plus 12 square is 144. So 169 plus 144, that gives us, so that will give us 313. Yes, 169 plus 144 gives us 313. And if I find the square root of the both sides, that gives me r square, the square root of it, and the square root of 313. So this square root will eliminate this square. Then my r will be the square root of 313 is 17.69 centimeter. So meaning that the radius from here to this place, the radius of this circle r is equals to 17.69 centimeter. So and that is what we are asked to calculate. So let's move to another example. Go to example 3. Example 3 says that the distance of a chord of a circle of radius 5 centimeter. The distance of a chord of a circle of radius 5 centimeter from the center of the circle is 4 centimeter. Then calculate the length of the chord. What are we going to do first? We are going to do our circle as usual. So drawing the circle here, put your center here. This is the center of the circle. So the distance of a chord of a circle of radius, the radius of the circle is what? 5 centimeter. Mind you, your radius can be like this. You can take it up like this. You can take it anywhere. But I like taking my radius like this. Radius just means half of diameter. Even if the diameter is here like this, then you clean one part, this place, this particular length is still your radius. So the distance of a radius of a circle, or the distance of a chord of radius, the distance of a chord of a circle of radius 5 centimeter. This is the radius 5 centimeter from the center of a circle is 4 centimeter. Please read that question very well. That means if we have our chord here like this, then the distance from here to here is what they mean by that 4 centimeter. Let me read up the question for you again. The distance of a chord of a circle, distance of a chord of a circle, this is a chord of a circle, the distance of it of radius 5 centimeter, the radius is here, from the center. Can you see it here? From the center here. So the distance of this from the center, this is the chord, then from the center, the distance is what? 4 centimeter. Why the radius is 5 centimeter? Then we are asked to calculate the length of the chord. We are asked to look for all these whole lengths. All these whole length. So you know that whenever I want to extract this right angle triangle out, I used to eliminate this part, this half part away. So in this case now, they asked us to calculate the whole length, not only the half part, meaning that the both. So let me give here x1, let me give here x2. Remember that they are equal. This line cuts these two x1, x2 into two parts, and this is a chord. So now if I should cut this thing out like this, which is going to be like this, meaning that my 4 centimeter is going to be here. Here will be my x2 and here will be my 5. I will have my angle 90 here like this. So now what am I going to do? Let me look for my x2. This x2 and x1, they are the same thing. They are equivalent because this line cuts this line from the center, cuts this arc into 2, cuts this chord rather into 2. So now what do I do? It still look like a right angle triangle. So I will still use Pythagoras theorem to solve this question by saying my hypotenuse square equals to the opposite square plus what? The adjacent square. So after that, my hypotenuse is 5, which is I'm going to square it, equals to this opposite is 4. I will square it, and the adjacent is x. So I will square it. Let me name it x2. So this is 25. If I collect my like term, 25. This one is 16 because 4 square means 16. When it comes to this side, that gives me minus 16 equals to x squared. I can put my subscript 2 here. So 16, 25 minus 16, and that gives 9. So I'll have it as what? 9 here. So therefore it's going to be x squared equals to what? 9. So if I look for the square root of the both, then the square root here, this square root eliminates this square. Then I have my x2, which is going to the square root of 9 is 3. So that means this x2 here, this part here is 3. This side here is 3. This place here is 3. So how will I know the length of the what? Of the chord according to the question. So the length of the chord will be equals to x1 plus x2. Remember that these two lines, they are equal. This half part and this also half part, they are equal, which is going to be 3 plus 3, and that gives me a total of 6 centimeters. So now let's move to the next example, which is what? Example 4, whereby example 4 says that the radius of a circle is 12 centimeters. A chord of a circle is 16 centimeters long. Calculate the distance of the chord from the center of the circle and give your answer to 1 decimal place. Now, the example 4 now, the radius of the circle is 12 centimeter. So the radius, like I said earlier, I like taking my radius like this. So the radius is 12 centimeter. Okay, a chord of a circle is 16 centimeter long. This is also a chord, don't forget. So it's 16 centimeter long. That's the chord. Calculate the distance of the chord from the center of the circle. The distance of this chord from this place, the distance from here, let me name here x. So still the same method, the same procedure with our previous example. I think example 1 also looks like this. So I will extract my triangle out. This is a right angle triangle, whereby this is my hypotenuse, which is 12 centimeter. This place, like I said earlier, is equal to, that means this part here is going to be 8. This other part here is going to be 8, because of the total is what, 16. So here will be 8 centimeter. Let me put it here, 8 centimeter. And I'm looking for this part, which is what? Let me name it x. So I will use my Pythagoras theorem as well, which says hypotenuse square equals to what? The opposite square plus the adjacent square. So the hypotenuse square, which is this side, so which is this 12, that will be 12 square equals to the opposite is what? That is x square, and the adjacent is 8, so plus 8 square. So 12 square is 144 equals to x square, and then 8 square is what? 64. So if I collect my like terms, and I will have it as 144 minus 64 equals to what? X square. 144 minus 64, that is 80. 80 equals to x square. And if I square root the both sides, that gives me square root of 80 equals to what? Ordinary x, because the square root here will eliminate this square of this on top of this x. So the square root of 80, and that will actually going to give me 8.9. And we are told that give the answer to one decimal place. So I will have to leave it at 8.9. One decimal place means one number after the decimal point, and that is this 9. So centimeter. And that is the what? That is the 8.9 in one decimal place is the distance of the chord from the center of the circle. Now this is a practice question for you to do. So in a circle of radius 6 centimeter, you are asked to calculate to one significant figure the length of a chord, which is 4 centimeter from the center of a circle. So if you want to solve it, you're going to draw your circle, then the radius is going to be 6 centimeter, and then the length of the chord is going to be 4, meaning that you are asked to calculate the distance of the what? Of the chord from the center of the circle. So, and then remember that your chord is going to be two together, because you're going to cut it, divide it into 2. So meaning that the chord, whenever you extract a triangle out, the chord is going to be 2 centimeter like that, and your final answer, remember to leave it in one significant figure, that is 1 SL. So try to practice this question. Let's look at this angle in a circle. Now we are in angle in a circle. So the first theorem I'll be explaining that is the angle subtended at the center of the circle is twice that subtended at the circumference. This place, this P here and this Q here, this A here and this B here, they are circumference of the circle. So this is the center of the circle. So what I'm trying to explain here is that you see angle AOB, angle AOB will be equals to what? 2 of APB will be equals to 2 of angle APB. Meaning that, let me assume like this angle here, let's say this angle here, let's assume it is 72 degree. If this angle here is 72 degree, that means this particular place can be around 36, it will be 36 degree. That means 2 of this place gives us the angle here. That is the meaning of what I'm trying to explain here in this theorem. 2 of this place here, no, 2 of this angle here will give angle of 72 degree. So meaning that, let me assume if angle here is, let's assume angle here is 24 degree. That means the angle here is going to be what? That is going to be 24 times 2, and that is going to be 48 degree. So that is what this theorem is talking about. Also, angle AOB, also the reflex means this part is the reflex. The reflex of angle AOB is equals to what? 2 of AQB. 2 of AQB. Meaning that if this place here is around 270 degree, yes, that means the angle here at this place, the angle here will be what? 270 divided by what? Divided by 2 will give you the angle you are having here. So that is the meaning of what they are saying, because this one is the circumference, this place to any angle touching this circumference, we call it angle at the circumference. Let me repeat myself again. Here, remember that this whole angle here gives us 360 degree. Everything here is 360 degree. So let's assume the angle here is 48 degree. This down one is reflecting, is working with the angle at this top, which is this P. If here is 48, then this angle here is going to be what? Is going to be 24. And also, if angle here, let's assume angle here is 270, we are assuming. That means the angle here will be what? 270 divided by 2. But don't forget that this angle here cannot be 270 because the sum of angle in this circle like this must give you 360. And that is what this first theorem is talking about. Now, let's go to this second theorem. This second theorem says that angle in a semi-segment, angle in the same segment are equal. Now, where are the segments? These are the first segment and the second segment. You can see segment like what I explained earlier to you when we are doing arc and chord. So now the angle here is that this angle here and the angle here, they are equal. So let's assume here is 32 degree. This particular place should be 32 degree. And P and Q, they are also equal. So meaning that APB, so angle APB will be equal to angle AQB. It becomes to angle AQB. And likewise, the same thing as angle PAQ, I'm referring to this place, PAQ will be the same thing as angle what? Angle A, okay, that will be angle PBQ. That will be PBQ. So they are the same thing. In a nutshell, this simply means angle in the same segment are equal. This is a particular segment. Segment means they are touching the same, like they are on the same length in the same circumference like that. And this is another segment we have here. So this angle here is the same thing. So if like 32, if 49 degrees here, 49 degree will also be here. If 32 degrees here, 32 degree will also be here. That is what this particular theorem is talking about. Now let's move to theorem 3. This theorem 3 says the angle in a semicircle is right angle. Look at this. This line passes through the center of the circle, meaning that here is a diameter, here is also a diameter. So like here is half of the circle, here is also half of the circle. So any angle that occurs here, they are called a right angle. And that means AXB. Angle AXB is equals to what? Is equals to 90 degree. So the angle here, look at what I put here. This means that the angle here is 90 degree. So all the angle here, any angle that forms here is going to give us what? 90 degree. So the angle here is 90, whereby here can be what? Here and here. Summing up the angle here, and this angle here will actually give us 180 degree. So that is what the angle here is talking about. Angle AXB is what? 90 degree. The angle is 90 degree. So addition of all this angle here is going to give us 180 degree, because addition of all the angle in a right angle triangle is what? 180 degree. That is what this theorem is talking about. So this last theorem, theorem 4, says that opposite angle in a cyclic quadrilateral are what? Are supplementary. So the opposite angle in a cyclic quadrilateral are supplementary. Now look at this. Now this is a quadrilateral because it has 4 angles, 1, 2, 3, 4, and it has 4 sides, 1, 2, 3, 4, 1, 2, 3, 4. Another example of quadrilateral we have is kite. Kite is a quadrilateral, square is a quadrilateral, rectangle is a quadrilateral, and so on. So opposite angle of a cyclic quadrilateral, they are what? They are supplementary, meaning that angle DAB is what? Plus angle DCB, plus angle DCB is going to be what? Is going to be 180 degree. That is why it is supplementary, meaning that if we sum up the angle here, let's assume the angle here is let's assume it is 32 degree. That means 32 minus 180 will give us the angle here, and that will be around angle 158 degree. I'm just guessing, giving an hypothetical value. Oh, sorry, that will be 148 148. So the meaning of this thing means that supplementary means when you add the opposite angle together, they will give you 180 degree. So that is what this theorem is all about. Now for this particular video, I'm going to give example based on this theorem 1 and the other theorem, which is this theorem 2, theorem 3, theorem 4, that will be in the next video. So let me give example based on this theorem 1. So in this example 1 now, we have to look for this angle x, this angle s. Now remind you, I said this example I'm giving on the board, which are example 1, 2 and 3 shown on the board, they are only pertaining to the first theorem I explained earlier. So the other 3 theorems that will be in the next video, all not to make this video too long. So now how do we get the value for this angle at this particular place? What is it going to be? Remember that this place, 2 of this angle here will give this angle here. Remember that 2 of the angle here will give what we have here. Exactly. So meaning that I can just say, let me name here A, B, C. So if I should name here A, B, C, so I can actually say, I can actually put this theorem as A, I can say AOC, angle AOC is equals to what? 2 of ABC. Exactly. That is perfect. So yes, so angle AOC is equals to what? 2 of ABC. So that is going to be angle AOC is equals to 2 times. Now what is, I'm referring to this particular angle that we have here, this particular one here. So meaning that ABC is 126 degree. Angle ABC is 126 degree. So angle AOC is going to go 2 times what we have here. Remember that AOC is represented as what? Letter S. So I can actually say letter S equals to 2 times 126. And 2 times 126, that's what? 2 times 6, that is 12. 2 here, this one is 5. And we have what? 2 here, that is 256 degree. So the angle we are going to have here for this S is going to be what? 256 degree. That is what this theorem is talking about. Now let's look at this particular place. This angle here is still the same thing with this particular one we have in this example 1. So this example 2, meaning that the angle we have here, 2 of it will give us the angle we have in this particular place. 2 of this angle here will be what this x is going to be. The same way we did this example 1. So let me still give it another value. Let me say A, B, let me just say C and D. That is just an hypothetical value. So A, B, C, D. Now let me write it in form of this pattern by saying angle A angle AOB for this particular place, this one we have here, will be equals to what? This x I'm referring to will be equals to 2 of angle ADB. Angle ADB. Yeah, as you can see, yes. So angle AOB, I'm referring to this denominator, this one down here. It is represented as x. So let me write x here, which is going to be 2 times the angle of ADB. The angle of ADB is 119 degree. So if I should multiply that, and that will actually going to give me 2 times 119. 2 times 9 is 18. If I write my 8 here, times 1 is here, 2 plus 3. Then the angle here is 2. That means 238 degree. So this x here is representing 238 degree. Now how do I get my y? Remember in the first example I said when you add all this angle together, it gives you 360 degree, meaning that x plus y will give you 360 degree. We already know our x should be what? 238. So if I replace my x with 238 and if I connect my like terms, my y will give me 360 degree minus 238, and that is going to be 360 minus 238. That should be y is going to be 122 degree, because it's going to be 360 minus 238, and we got the 238 from where? From the value of x. And I told you that the addition of all the angles here, because that is the angle of the sum of angle in a circle, that gives us 360. So that was how we got this 360 degrees. So when we subtract 360 from 238, then we got 122. So I've gotten x, I've gotten y. I got x should be 238, y should be what? 122. Then the next one is to get is z. So for we to get this z, that is going to be AOB, angle AOB, I mean the reflex of AOB, which is this y, equals to 2 of ABC. So ABC representing this z. So this angle AOB, that is this y. So y is going to be 2 times what? ACB. ACB is what? This z. So we have this z here. So y will be equals to 2z. So what is y from here? Y is 122. We have here should be 122 degree equals to 2z. And z is going to be 122 degree over 2. And that is 61 degree. So the answer for this, the value for this z is 61 degree. Now let's move to this last example 3. That's the last example. So looking at this triangle inserted into a circle. So let's give it a name. Let me give here A, let me give here B, and let me give here C. So we are asked to look for angle ABCD. Now let's start from angle A. Angle A will be equals to angle A. This small letter is going to be equal to 43 degree. Why? Because it is vertically opposite to this particular 43 degree that we have here. So if this angle A is 43 degree, yes. Why? The reason is because of what? It is vertically opposite to this particular angle. You can see the angle here. They are opposite to each other. So that's why it is the same thing as 43 degree. Then we move to angle B. Now looking at angle B now, angle B is going to be gotten from this D, but nevertheless we can get this C first. So getting this C first is going to be what? This is looking like, this is an isosceles triangle whereby this angle here and this angle here, they are the same, they are equal. So angle A will be equals to angle C. So A equals to C because of what? They are parallel to each other. No, they are isosceles triangle. So if A is 43, then C will be equals to 43 degree as well. How do we get the B? So the angle B is going to be the sum of A plus C plus B, and that gives us 180 degree. So if we have it as A plus what? Angle A plus B plus C equals to 180 degree. So if A plus B plus C is 180 degree, we already know that A plus B, that would be what? 86. Because 43 plus 43 is 86. 86 degree plus C equals to 180 degree. And C will be equals to 180 degree minus 88. 180 degree minus 86. And that will give us the angle of, that will give us angle 94 degree. So angle B rather, B. So the angle here is B, because A plus C is 86 degree, and B is going to be 180 degree minus 86, and that will give us 94. So C here is 43, while B here is 94 degree. The B here is 94 degree. And the last one we are going to look for is the angle D. Then we are left with what? Angle D. So remember that from the previous theorem we have been working about, then we are going to use it to get this angle D. Remember that this B here, the angle for this B here is working with the D we have at this particular place. Why this down one will be working for any angle we have at this circumference, something like this. This X here now is working for this 119 degree, and this Y here now is working with this Z. So the same thing will also happen here. This B here now will be working with this D. Why any angle we have here will be working with anything down here. So now this is going to be angle AOC. Angle AOC will be equals to 2 of ABC. 2 of ABC. And remember that AOC, that is represented as what? Letter B. So small letter B will be here, equals to 2 times ABC. ABC here is represented as what? Letter D. So we have D here. I already know my AOC should be what? B. And the value for B is 94. So 94 will be here, equals to 2 times D. I am looking for this D here in this particular place. So from here I can say D equals to 94 divided by 2. Yeah, because if I should divide the both sides by 2, I will get my D equals to 94 over 2. And that will be 47 degree. So that's going to be 47 degree, because 94 over 2 is 47 degrees. So the angle for this D here is going to be 47 degree. So again, I have my angle A should be 43 because it is opposite, vertically opposite to this value we have here. Then A is equals to C because both of them, they are the same base, and this is like an isosceles triangle whereby they have the same two sides are equal and the base will be the same thing. So when we sum up these two bases together, then subtract it from 180 because sum of angle in a triangle is 180 degree. That gives us this B, and the B is standing for 94. And then we have it here by saying the AOC, which is equals to what? 2 times what? ABC, from the first theorem we have been working on in this. So now from here we can represent this place as B, which is here. Then 2 times here should be what? D. This particular place here is D. So solving this, we get our D is equals to 47 degree.